Right, we've got, we need to find the next term of this sequence. All right, these are going up in equal steps. So it's 5 add 4 to give the 9. 9 add 4 does give you 13. And then add 4 does give you 17. You want to know what is the next term of this sequence, so you just simply add 4. 17 add 4, 21. Write an expression in terms of n for the nth term. Right, we're looking for the nth term. So that's the topic. So if you look at this, it's going up in steps of 4, so you write 4n. Right, these are going up in steps of 4, so you write 4n. If they were going up in steps of 5, you'd write 5n. If they were going up in steps of 7, you'd write 7n, etc. But then now we need to know what comes before the 5. So we've got 17, 13, 9, 5. So to go backwards, we do take away 4. So the number that comes before 5, 5 take away 4 is 1, positive 1, positive 1. There you go, that's the nth term. You can use this to find the 100th one, like we got here, first, second, third, fourth, fifth, sixth. If you want to find the 100th one, you don't want to keep on adding 4 all day. To find the 100th one, for example, you can replace the n with 100. So that'll be 4 times 100, and then add 1. That'll be 401. So that's the nth term. Right, in the space below, draw pattern number 4. Right, first of all, you need to recognize the pattern. So I can see here you got 5 dots. The second pattern, it's also got the 5 dots here plus an extra 3. Right. So you can see it's added on it's added on an extra 4 dots. Sorry, an extra 4 dots to the pattern number 1. For the third pattern, you've got that one here exactly the same, but it's added on another 4 dots. So it looks like to get the next pattern, we're going to copy that, copy exactly the way it is, and then add on an extra 4 dots. All right, so that's what I'm going to have to copy. I'm going to have to copy that. I'm going to have to copy pattern number 3. So that's 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3 at the top with gaps, 3 at the bottom with gaps. Right, that's pattern number 3, but to get pattern number 4, we've noticed you have to add on an extra 4 dots. 1, 2, 3, 4. There you go, that's pattern number 4. Right, it's asking to complete the table. Well, we can see clearly it's adding 4, adding 4. We're adding 4 dots each time. This is actually, in a way, same as question 16. Right, we've seen these numbers here before, 5, 9, 13, 17. We've got the same pattern here, but this time we've got the same number pattern here. So all we're going to do, keep on adding 4. Right, there you go. Find an expression in terms of n. Find an expression in terms of n for the number of counters with pattern number n. Right, that's the nth term. We just did it just a while ago. We just did it with the other question. So these are going up in steps of 4. So you write 4n, and the number that comes before the 5 we saw earlier on was 1. That's the answer. Habib has 50 counters. He wants to use as many of his counters as possible to make a pattern in the sequence. What is the number of the pattern he can make using the greatest number of his counters? So he's looking for pattern number with 50 counters. So we had 5, 9, 13. I'm just repeating these numbers again. Add 4, add 4. Right, if you add another 4, it'll be more than 50 counters. So that's pattern number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's the 12th pattern. With the 12th pattern, you can have 49 counters. Habiba's got enough for that.